Hello, welcome to ANS Solver. This is the sixth question of the paper, and as you can see, this is a numerical solution question later. Okay, so let's start with the part one. We need to use a triangle OAB to show that AB is equal to 2r cos x. Now, see, this requires a little bit of common sense and a little bit of imagining. What I can do is, I know this is a semicircle which is given to me, correct? That's what I know. I can extend this line here and make a full circle, let's say. Let's say I make a full circle, so this line will be extended. I know this dotted line is also R because R is the radius, correct? And O is the center. So I know this dotted line is R and the dotted line here is also R. Now, if you see, I can make a triangle here, something like this, correct? Which I can state that this is 90 degrees. So if you see, I have a triangle here. Okay, I'll just draw the triangle. Sorry, my bad. I'll just draw the triangle here, correct? Where I can say that there's an angle X. Okay, there's a 90 degree. Okay, this is basically AB, correct? So I can state my angle, this is AB. Okay, I don't know the length here, correct? I can't state that. But I know the length from A to this point here is 2r because of r plus r. So I can state that this point here is simply 2r, my hypotenuse. Got it? So now I know that cos theta is always equal to the adjacent over the hypotenuse. So I can write this as cos x equals to the adjacent, which is AB, over the hypotenuse, which is 2r. So I can simply state that AB is equal to 2r cos x, which basically we needed to prove. Okay, so a little bit of imagining skills, is required here. But yeah, easy sum to solve, don't worry. Now, hence show that x is equal to cos inverse of root of pi over 16x. So now see, if you read your information carefully, what I'll do is I'll simply remove these lines here so that it's easy for you to understand what I'm saying. Okay, so if you see here, they are saying the area of the shaded region, okay, bounded by AB and AC is, and the area of center A is equal to half the area of the semicircle. So I can say the area of the shade or the shaded area is equal to half into the area of the semicircle. So the shaded area I can say is basically a sector, if you see, in a way. Correct? This is a sector. It has a radius of, let's say, AB, and the total angle here is 2x. Correct? Because AB is the radius and 2x. So now my shaded area will basically be 2x over 2 pi into r. R is basically AB square, correct? Because the area of sector is basically theta upon 2 pi into pi r square, correct? This is the formula. So now I can say this is equal to half into area of a semicircle is simple, which is half into pi r square, correct? This is what I can write. So now I can simply cut 2 here, I can cut pi here to get AB the whole square into x, which is equal to basically, I can take half inside to get 1 over 4 pi r square. Correct? This is what I can write. Now, in the above part, I saw that AB can be written as 2r cos x. So, in the place of AB here, I can simply put 2r cos x the whole square into x equals to 1 over 4 pi r square. So I can simply write this as 4r square cos square x, okay, into x equals to 1 over 4 pi r square. I can simply cut r square here, correct? So I have cos square x equals to, I can write this as pi over, when I take 4 that side, I get 4 in the denominator to get 16, 4 into 4 is 16, and I can simply get x here in the denominator, correct? So now I can write this as cos square x or cos x equals to the root of pi over 16x, which can be written as x equals to the cos inverse of the root of pi over 16x, which is basically what I had to prove. Got it? Yeah. So simple sum needs little bit of understanding. Yeah. Now verify by calculation that x lies between 1 and 1.5. So I know my x here, basically I'll just write it again. I know my x here is equal to cos inverse of the root of pi over 16x. So now what I can do is I can write this as x minus cos inverse of the root of pi over 16x. I know this is equal to 0, but I don't need to write it. Now what I can do is I can take my x first as 1 and I can take my x as 1.5. So when I take my x as 1, what I can do is I can simply put 1 here in the place of x. Got it? So now make sure you are on the radians mode on the calci and just simply solve this. Even I'm solving it, give me 1 second. Okay, so now when I basically, make sure you are on the radian mode, because see, if you're not on your radian mode, you'll get your answer in the degree mode, which will give you a big value which will not be correct. So yeah, just give me 1 second, even I'm calculating it. Yeah, so when I do this, I get my answer as negative 0.11172. I don't care much about the value, I care about the sign. If I see this is negative, and now what I need to do is in the same place I need to put 1.5 in the place of x here. So on the calci just put 1.5. Okay, simple. In the place of 1 just put 1.5. So the value I get here is 0.299994. Okay, so if you see here, this is a positive value. So I care about the signs. So I can say if there's a change in sign between both of these values, I can say that x lies between 1 and 1.5. So I just need to write change in sign, hence verified. Okay, this is what I can do. Now use an iterative formula based in part 2 to determine x correct to 3 decimal places. So I know my iterative formula can be written as x n plus 1 equals to the cos inverse of pi, actually root pi, over 16 into xn. So my first step is to take n as 0. So when I take my n as 0, I get my x1 equals to the cos inverse of root of pi over 16 into x0, because I have only xn here, correct? Now I can take my x0 as I can take it basically as 1 or 1.5 because I know x lies between them. So for now, let me take 1. So when I take 1, what I can do is I can write this as cos inverse of the root of pi over 16 into 1. So now write exactly this on your calci. Make sure you're on the radian mode. Okay. So yeah, when you write this, you get the answer as 1.111. I need to give each iteration to 5 decimal places. So 7, 3. So I have x1 here. Now for x2, what I need to do is, instead of putting 1 here, I need to click on the answer button on the calci. So remove 1 and click on the answer button and click on equal to. So I get 1.13707. Now for x3, what I can simply do is I can just click on equal to get 1.142. Just click on equal to, no other button. Now you can keep on spamming the equal to button. So now when you see, you get this as 1.143535. Now you get x5 as 1.143534. Okay, here. Now I get my x6 also as 1.14354. Now if you see here, the iterations are recurring. Okay, they are recurring. So I can say how many ever times I click on equal to, the answer I get will be 1.14. I need to write my answer to 3 decimal places. So 1.144, which is basically the final answer of my question.